Oh, hey there. It's everybody's favorite chapter, CCNA1 9, subnetting. And I think we all know where we're going with this. Anyways, if you don't, we're going to explain why networks need routing, describe IP communication, used to identify a single device on a network, given a network and subnet mask, calculate the number of host addresses, calculate the necessary subnet mask in order to accommodate a given number of hosts, describe the benefits of variable length subnet masking, VLSM, design and implement a hierarchical addressing scheme, explain how IP version 6 address assignments are implemented in a business network. Sounds like a good time to me. So we're going to skip straight to network segmentation. Reasons for subnetting. Okay, well, why do we want a subnet? Well, because, one, it makes it easier to manage. And two, we need to conserve IP addresses, so we subnet. So in the past, it was common to have all networks, or all host devices in the same network. Well, that's not very safe, right? Because then a limited broadcast such as this hits every device in your entire network, and, well, it just leaves you open to vulnerability. So one reason we subnet is to segment people from each other, or departments, right? So, like, maybe we could segment these guys out. Right now in this drawing, as you guys can see, they're all in the same network, most likely. We can't see the subnet, so we don't know. But some things to go over while we're right here. This right here is called a limited broadcast, 255.255.255.255, right? Which is the last possible address we could ever use. And so what it means is in any network, it's limited. It'll broadcast in any network, but it's limited to stop right here. The opposite of a limited broadcast is a directed broadcast. That's where we actually put in a network address, and then the last host number is the broadcast. This one is not the last. We don't see the last because, well, as we all know, there's two hosts. There's two numbers we can't use. One is the network number, and one is the broadcast. And so if we did a directed broadcast, that means that someone could actually come from out of here and broadcast into here and have all of these hosts reply. We need extended ping to do this. But anyways, probably getting ahead of ourselves, and I think we still have that to talk about. But that's the difference between a limited broadcast, which means it can only broadcast inside of here. But a directed broadcast, this computer could point to another network and still broadcast to it. So, and that's called a directed broadcast. Anyways, that's pretty much, I think, everything they're talking about here is just that we can start segmenting. Alright? So, after we segment, we also need, so like if everybody was on the same network, if we only had computers that just need to talk to each other, we would just need one of these guys. Also known as a poorly drawn switch, right? And so if you're in the same network, you can all be connected to the switch in the same, what we call VLAN, or same network. And so we could just have this and it'd work out. But when we start making different layer 3, because remember subnet is a different layer 3 segmentation, so it's going to have different layer 3 addresses, known as an IP address, right, or a logical address. And what we need then are these things right here, these routers, okay, because routers route between networks. So if this is a different subnet, we need to route there, and then we need this to route up to here, and this guy needs routes down to here to route to the other subnets as well. So that's what establishes, as it says, a router is necessary for devices on different networks to communicate. So each subnet is a different network. That's what it means. It means we take one network and we break it into multiple networks, or sub-networks, right? And so that is what a subnet is, and we need a router to divide it. Alright, subnetting fundamentals. Well, first we need a plan, right? And so in this one, right, we have a student network, a faculty network, and an admin network. Alright, so we're going to break them into three. Then the second thing we need to find out is, if we're going to use the same subnet everywhere, we need to find out which one of these networks has the most hosts and make sure we have enough host addresses for each subnet. And so those are the two key things that we're looking for, right? So planning requires decisions on each subnet in terms of size, the number of hosts, and how addresses will be assigned. And what we're talking about probably on addresses there is, I don't know, we might be setting statics for these servers. This printer should be set static, right? The server. But also, this router up here is how we get out, and hopefully you remember that the router, then the way out of a network is called a default gateway. And so we probably want to set the same number for default gateway for each subnet. So each subnet's second to last address, not last because last is the broadcast, but second to last would be its default gateway, or maybe the first usable host on a subnet will be the default gateway. So that's part of the plan. Alright, so here we go into the plan. Printers and servers will be assigned static IP addresses. Users will receive IP addresses from DHCP servers using /24s. Routers are assigned the first available host address in the range. Basically just what we talked about. So if you want to see that again, go ahead and read through that. Alright, so basic subnetting. And every subnet is going to follow these rules, right? We have the one portion, right? We have two types of bits in a subnet. Well, we actually have three, but we're only going to talk about two right now. Ones are network bits, defining where the network is. So if there's a 1 there, it's part of the network. If it's in zeros in the subnet, the zeros of a subnet are hosts. So if it's in the zeros, it is a host address. And that's our two types of bits. Okay, so what's the subnet mask showing? Where our network stops and our hosts are. Okay, so how is it doing that? Well, I don't know what they're asking right here. Let's see, the borrowed bit value from 0. Yeah, I guess what they're saying on here is they're making a new subnet mask. They're splitting these in half. Yep, that's what they're doing. Alright, so our original subnet mask was just a /24, and so they decided to borrow one subnet mask, right? So up here with the /24, that means we have 8 ones here equaling 255, 8 ones here equaling 255, 8 ones here equaling 255. If we add all of the 8s together, that is a /24. So that's what we mean by a /24. It looks like this. Now we can start using 1, so this is actually a /25 because we're borrowing 1 bit to make the networks, to make more networks and have less hosts. So we just lost a host bit and a network bit, so we're going to have less hosts and more networks. So our host bits tell us how many hosts on the network there are. We have 3 and 4, so 7. So 2 to the 7th tells us that our host bits are, we have 828 hosts. Okay, that's a 2. 2 to the 7th. Okay, 2 to the 7th, where do we get the 7? There's 7 zeros right here. Okay, if we look at our original, there's 8 zeros. 2 to the 8th is 256. That's how we can find out our block size. And where we find our network is, as we can see, the network starts right here. And so what they're doing is they're breaking this into binary, and a 1 in the 1 column right there is 128, and that's the network. So the two networks we can have before we go to the 2 network are 1.0 and 1.128, because we have split our subnet our subnet again has 2 to the power of 7, which is 128 hosts, and if we had 8, it would be 256. So between 192.168.1 and 192.168.2, there are 2 subnets now by borrowing 1 network bit here. Okay, so the borrow bit is our other bit that we have, and I don't like talking about it yet because it's just going to confuse you, but it tells us how many networks we'll have. So if we have one borrow bit, we have two networks. If we have two borrow bits, we'll have 4 networks before we go to the next upward digit on the third octet, or if we're in a class C, or in a class B, the second octet, or in a class A, the first octet. Okay, so borrowed bits are the ones away from the classful mask, the ones that we're borrowing away from the classful mask, and they tell us how many networks until the next, until we have to borrow a bit from the next octet. Okay, and that sounds really confusing, so hopefully we get into some easier stuff before that happens. But the important things here are we can find host size by these host bits. We can find network by where the ones stop. So yeah, like if we had anything above 128, and we're going to get to ANDing here pretty quick, so then it'll be even easier, but it will always be 128 on that network if it's either going to be 0 or 128 here. The network is always going to be one of these two. That's our only two options if we have a 1 right there. Changes, we borrow another bit. But anyways, before I get ahead of myself, let's keep going. So here's our /25 again. Remember, the 25 is called a prefix, and it just tells us how many ones or network bits are in the subnet. So that's what that is. And it has broken this into 2 networks. Alright, so this network can only send to itself until it connects to a router, and this network can only connect to itself. So we've separated it out. So each one has a different broadcast, different network number, and its own hosts. And so our address range, what it's showing us here is on our first network. If we have all zeros, that's our network number. This is our first network, right? 192. So the network number is 192.168.1.0. The first usable host, well, we can just put a 1 in there. This would be on any network. It's going to show us the first usable host of 1.1. Then our last host address is going to be all 1s except for 10. And so our last assignable address is 192.168.1.126. Then our last usable is putting all 1s in the host bits, and it would show us 127, and this is our broadcast. So this is our broadcast. We can never assign this last usable host. This is the first usable address. This is where all of our host bits are at 0. Our broadcasts are where all of our host bits are at 1. Now, I didn't say network bits, that's why this stays to 0. But all of our host bits are. So if we want to find any broadcast or any network address, the first host, last host, or any host in between, we can find them by using the host bits. Okay, so now we're on our next network. Okay, so our next network, this is showing a 1 in binary. Okay, so don't think of it as a 1 there. It's a 1 in the 8th bit, so it equals 128. That's why all zeros here equal 128. But this once again shows us our network because these are our host bits, and if they're all zeros, that's our network number, which is 192.168.1.128. Just as with the last one, this is still 128, so we just have to add on to it when all of the 1s are there, and all the host bit 1s are there, and it would show us that it is at 255, and that's the broadcast for this network. So we can assign any address in between 128 and 255 based on the host bits that we know. Okay. Alright, so now here is, hopefully you guys remember this command, but here's how we assign an IP address. So we have interface G00, IP add 192.168.1.1. Why? Because that's the first usable host on this one. And then we assign 192.168.1.129, first usable host on this one. And notice the subnet mask is a /25 or a 255.255.128. Okay, so yeah, and they assign the host another one. What do they assign the host? I don't know. I can't see it. 130 it looks like. So the next usable host. Okay, so that's subnets in use. So how do we find these subnets? Alright, here back to the number of subnets. I don't like this. I usually wait a while to do this, but okay, so what it's going to do is, so we're going to assume, or we probably knew, that we subnetted this from a /24, right? Class C's default mask is a /24. And so anything we borrow above a 24 is a borrowed bit. On this one, we know that we borrowed a 1 right here. And so to find how many subnets that will make us, it's 2 to the power of 1, which equals 2. Okay? How do we find the subnet? How many hosts? 2 to the power of 7. How many host bits do we have here? 2 to the power of 7. So we'll have 2 networks of 128, but it's 128 minus 2 because we have to subtract. We cannot use, remember, the network address or the broadcast. So we have 126 assignable hosts, but between 192.168.1.0 and 192.168.2.0, we have 2 networks. That's what this is telling us. And I think that's what they're showing on the next one. 1 bit, 2 subnets. Okay, 7 host bits, 128 hosts, 126 host addresses we can assign. All right. So if we want a certain amount of networks, like say, we only have 4 hosts per subnet, then we don't really have to calculate how many hosts we need. We just have to calculate, no, I have 6 departments. So how do we find 6 departments? We just go by 2 to the power of anything. So if I take my original network and I borrow 1 bit, that would give me, again, it would give me 2 to the power of 1, which is 2. Then I borrow another bit, and so both of these would be 1s at this point. Well, actually the subnet would be. So let's go back and we'll go like this. So we borrowed 2 of those host bits, made them network bits, so we'd have 4 networks, but we need 6. And so then we borrow 1 more, that would be 2 to the power of 3, which is 8. So we'd have 8 networks, okay? Then, if we want to know how many hosts we have 1, 2, 3, 4, 5. 5 host bits, 2 to the power of 5, which is, let's see, what is that? 2 to the power of 5 would be 32, I believe, because 2 to the power of 4 is 16, 2 to the power of 5 is 32. So we have 32 total addresses, minus 2 for broadcast and network, and so we'd have 30 assignable if we were trying to find these. And that's basically what this is just saying right here. So if you want to find the network address of any of these, once again we keep all these at 0. First host broadcast, same as what we were doing before. Anyways, that would give us, that is how we find the amount of subnets we need and the amount of hosts. We could also go with, hey, we could just say, well, right now we have a 192.168.1.0 to subnet, so we have a /24. Now we could have more hosts if we were doing a 172, like class B, right? Because it's a /16 by default. But we don't have that. We have a /24. And so we say, well, I need 60 hosts. Alright, so we can go and we can say, oh, what's the closest to 60? Right, because the closer we get to 60, the more networks we have for future expansion. And so we say, alright, so 1 host bit gives me 2 hosts. 2 host bits give me 4 hosts. So forth. So 3 host bits give me 8. 4 host bits give me 16. 5 host bits give me 32. Right? And remember, these are host bits. It's where the 1s stop. So we can say 1, that gives me 2. 4, 8, 16, 32, 64, and I was asking for 60, so we know that that's how many host bits we need, and so we would make the rest 1s, right? Which would give me 8, 16, 24, 26. It would give me a prefix of /26, okay? So if I want to know how many times I could subnet it with this 192.168.1.0 not changing to 192.168.2.0, I would go the host bits, and it would be to the power of 2, which is, I would have 4 networks with 60 hosts. So hopefully that worked for me. Okay. And so hopefully that's making sense. Anyways. Now we're creating 8 subnets. Well, we already did this. It's, to the power of 3 gives us 8. Alright, so we borrow our network bits, go clear out 3 to 3, and we can find our hosts, we can find our network by having all zeros after the network number. And if we want to find the broadcast, it's all ones after the network number. So that same deal as before. Go through that if you're still not getting it. These activities probably would be convenient if you want to do them. Alright, so creating 100 subnets with a /16 prefix. So how are we creating subnets? Remember, those are borrowed bits. So this is a 172. A 172 is a class B. And so a 172 as a class B, how we're going to start borrowing our first borrowed bit, if we're at a /16, is going to be a 17, 18, 19, 20, 21, 22, 23, 24. Now I know that we can stop there to get 100, but how did I find that there's 100? Well, if we go back here, we're borrowing 1 bit. Remember, that gives us 2 networks. We're borrowing 2 bits. That gives us 4, 8, 16, 32, 64, 128. So actually we have more than 100 subnets, but when we do these, they have to be, I mean, it's not, we can't do exactly 100 subnets. We only have so many numbers we can do. It's kind of like cutting a board. You can only, if you can only cut it in 128 foot lengths, you're not going to get 100 feet. So you just do the best you can, get the closest you can. This is going to waste the least amount that we possibly can. I mean, if we had 128 networks, I guess this gives us a little bit for expansion too. That's another nice thing to plan for, right? And so, yep, that's how we get 128 networks, the borrowed bits, right? So how many hosts do we have per network? Well, it's the same thing. We just count our zeros. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Okay, so 2 to the power 9 equals 512. How do I know that? Well, hopefully you guys have memorized that 2 to the power of 8 equals 256. If we double that, we get 512. We minus it by 2 for our broadcast and network, and we have 510 assignable hosts, and we have 128 networks from 172.16 to 172.17. That's actually what this is saying, .0.0. Okay, so between 117.16.0.0, we can subnet it with a slash. What was it? 1, 2, 3, 4, 5, 6, 7. 7 plus 16 equals, what does that equal? 23. Okay, so a slash 23 gives us 128 networks. How else could we find that? Well, we take a slash 23 and subtract it by a 16, which is the classful boundary, and we get 7. 2 to the power of 7 equals 128. Okay? Alright. Calculating the host, we just did that, but take a look at the host bits. We have 9 here, so 2 to the power of 9 equals 512. Okay? So each network's going to have 510 hosts that we can assign, but 512 total with the broadcast and the network address. Alright. Calculating hosts. So say we need 1,000 hosts. How do we find that? Well, we have right here 2 to the power of 8, is 256. So 9 host bits would give us 512, and 10 host bits would give us 1024. 11 host bits would give us 2048, and so on and so forth. But I said 1,000, so we need 10 host bits. So just 2 here and 2 here. That's how we would get 1,000. So basically all of this is just calculating binary math. Now we're using a class A, right? And so if we just needed 1,000 hosts, right? So if we only needed 10, it's going to stop here. How many networks would that give us? Well, so now we're borrowing, we have a /8, and so we're asking from 10.0.0.0 to 11.0.0.0. How many let's see if that's 10. If you guys want to find this, we need 10 host bits, and we have 32 bits possible, so it's a /22. So how many times is a /22? How many networks with the /8? Well, as you can see, there are, would that be 14? So 2 to the power of 14 should give us a lot of networks. 2 to the power of 10 is 1024, so we'd be at 2048, 4,000, 8,000. It'd be over 8,000 networks is what we'd have with this. What are they actually doing? They have a lot more than 10 host bits. So I'm not really sure why they're they wanted to make 1,024 subnets. All right, so we made 8,000 subnets. They're making 1,024 subnets. How many hosts that give them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That can't be 14, can it? Okay, 6 plus 8. Yeah, that is 14. So 2 to the power of 14. Isn't that what we just had? And so it would be 1,000, 2,000, 4,000, 8,000, 16,000 hosts, I believe. Let's see. So 2 to the power of 10, 1,020 would be 1,000. 2 to the power of 11 would be 2,000. 2 to the power of 12 would be 4,000. 2 to the power of 10, 11, 12, 8,000, 16. Actually, we're getting 32,000. Okay. I believe on rough math. So you could also just put into your calculator 2 to the power of 14, but make sure you can do it in your head because you cannot use a calculator on the certification, which I can promise you, no matter what certification you take, there will be subnetting, and they will definitely ask you what the network address is, what host addresses you can assign, and what the broadcast is. So, alright, so subnetting based on host requirements, we know this. We just need to find the amount of host bits we need for a certain size. So we have to determine our size, then we just take 2 to the power of that, and so we make that number is the zeros, so we just count to 2, make that the zeros, the rest of the zeros will be 1, so we can just take 32, minus it by the host bits, say we needed 256 hosts, /8 will give us a /24, and so that would be our prefix, or 255, 255, 255.0. Okay, so hopefully that's making sense. Subnetting on this would be 2 to the power of borrowed bits, so it depends on the classful, what we're starting out with, right? And so how we're going to choose class B, class A, class C is the size of our network. So if we're in a real big place that needs a lot of networks and a lot of hosts, class A is the way to go. And our class A private address is 10.10.10. And the reason we go with that is because it's a /8. So it has billions of hosts to start out with, and then we can have thousands of networks and still have thousands of hosts. If we don't need quite that scale, class C, which is 172.16 to 31, right? We do that. If we only need hundreds of hosts, we can do a /192.168.1.0. And actually, we could go bigger, because we would just start. The thing with the 192.168 in the class C is, we can borrow. We can borrow in this or not this octet. This has to be the same to be private, but we can borrow. We can go up to 255 in that octet there. So if we need to, we start at 0 and go to 255 here. So we can still have quite a bit of networks. It's just a little, I don't know, I guess it's just the same. So that's how we pick which class we are and where our borrowed bits are going to be. Because with each one, our borrowed bits, right, if we're going to class C, like I've said before, it starts at a /24. So we're borrowing from there. So /25 on a class C is going to be one borrowed bit cut into two networks, whereas a /25 with a /16, right, or class B, is actually 11 borrowed bits. No, 9 borrowed bits. Sorry. So 9 borrowed bits, which would give us 100. No, it would give us 512 networks, right? And so basically, as you can see, the borrowed bits is a lot more complicated than the host bits. Host bits is always the same. If you have zeros, they're going to tell you how many, but the number of subnets they're asking is based on borrowed bits. So I'm going to keep going because I think you guys read through here if you need it, but it's basically just subtraction based on finding your host bits. So you just multiply by 2 to find the number you need for each, such as 25. We just find a number that goes into, so we go 2, 4, 8, 16, 32. Guess what? 32 works for all of these, so that would be the one we used. Unless we want to subnet, we could put a different subnet on for each one. If we put a different subnet on for each one, we go with the largest subnet first, then the next largest, then the next largest. This is just going to make the numbers prettier, and I'm not going to get into that yet because they don't really ask you to do that very much anymore. But anyways, when we are putting different masks, like where we don't have them the same, what I was just talking about, that is called VLSN, and it's where we put a different subnet mask on each different network. They're varying sizes. So, and on this picture they broke a bunch of /30s into different ones. That's neat. It's just the same as what we've been doing. Just instead of with a /24, we are starting with a /30 and making it smaller, but they went back to a /24. So what we're doing is, like back to here, we would use a 25, our best mask without wasting the most hosts. As I said before, would be if we had 1 host bit, we have 2, right? So 1 would give us 2 host bits. I should probably do zeros instead of network bits. Alright, so 1 0, 2 hosts, 4 hosts, 8 hosts, 16 hosts, 32 hosts. Alright, so that's going to fit this the best. Alright? And actually, it's going to fit all of them the best, besides it's going to fit this one, and this one, and this one. And actually, it's going to fit this one as well, because if we went back down 1 to a /16, /16 minus 2, we can't assign, we only have 14 assignable addresses, so it's going to be the best for all of these. So that's the same as what we're doing. Do they have any places where we could actually... Nope, they're still giving these all /27s. Okay. preventing and assignment. I don't know. This is all common sense. So can't have duplicate addresses. I think that's already known from hopefully the networking chapter. You figure that out. We statically set stuff that we don't want to change, because I'm sure you guys have experienced printers changing and then you have to re-add a printer and it's a pain. So we statically set printers, we statically set servers, because all these guys are probably going to access them all the time. So we statically set that. We've already talked about that. And we split things, probably, you know, we're separating these networks so that, I don't know, accounting, some guy can't get hired in accounting and just watch all the numbers, even though, or some guy from maintenance can't get hired, get on a computer and steal all the information from the broadcast. It would take a little bit more trying than just being all on the same network. Yeah. Anyhow, what do we need IP addresses for? And clients, servers, peripherals, hosts that are accessible from the internet, intermediary devices, and gateways. Alright, so that's what we have to plan for. If you've never thought about that, hopefully you have. DHCP assigns IP addresses dynamically. So usually that's just for client devices. Then servers, as I said, servers and devices are going to be statically assigned. Alright, so now we get to go into the fun stuff. Subnetting, IP version 6. Well, IP version 6 is usually subnetted in nibbles if we're lucky, and since you're going to be the network administrator doing it, that's what it is. So what we're looking at is a /64. And so typically with a /64, our global routing prefix is what's given to us by an ISP, or it's our link local, or whatever it is. But what they're talking about here is this would be given to us by ISP. So then this number is what's called the subnet ID. And so what a /64 says is just the first 64 bits are ones. And so these all have to be the same. It's the exact same as IP version 4 subnetting, except when we break down the numbers, they're a lot longer because this is 64 bits, right? And if we did all of an IP version 4, it would only be 32. So this is all ones. And then what it means is we have 64 zeros left over. So 2 to the 64, actually be 4 to the 64, I believe, would give us the amount of hosts we have left. So that's what's fun, right? And if you look at here, what I was saying by all 64 have to be the same to be in the same network, right? So that means 0 in this has to be the same. 1 be a different network, 2 would be a different network, 3 would be a network, 5, so on and so forth, all the way to FFF, right? So that's where we went all the way to F, and we started back at 1.0, 1.1, 1.2. Those are all different networks. And so IP version 6 really isn't that hard to subnet. It's just that it's big numbers, so we get scared of it. Let's see what we have here. So our /64, hopefully you guys are seeing that all 64 bits have to be the same to be in the network. So everybody would start off with this and then have an address, such as this router has ::1 and this PC has ::10. Alright, that's what that's saying. It has 2001 DB8, a CAD 1 is the address, ::1, and this one is 2001 DB, a CAD 1, ::10, right? Whereas this is 2, 4, right? So that's pretty easy, right? We see the next network pretty easy. It's just a different number. So it's unlike subnetting where, you know, if we go past a classful mass like a /25, the number is going to be, one of our networks is going to be .0 and the other one's going to be .128, and then we would have like 2.0 and 2.128, right? So IP version 6 is a lot easier than that because we can actually see it. And if you guys don't know how, here's how we assign IP addresses, IP version 6 addresses, but we've already had it, so hopefully you know. Alright, so now, when we subnet IP version 6, now why would we want to subnet? Because we have tons of hosts, so we don't really care. Well, we have too many hosts, so we want to better monitor our network by making the network smaller. And so how we do that is we subnet at nibbles. We either subnet or supernet at nibbles. So, which means 4 bits. And so we have 64, 68, 72, 76, 80. They have to be divisible by 4, I guess. Right. So 84, 88, right, all the way to, I don't know, we go to 128, I guess, if we didn't want any host bits, but, so 124 would be how far we cleared 124. And 124 would give us 16 hosts, okay? And so, how do we know what has to be the same? Well, if we go to a 68, this is what it's showing, a 68, then clear to here has to be the same. This is where subnets get confusing. We would have to write this network as 0, 0, 0, 0, right? Because remember, we don't have to write continuous zeros, so colon 0, that is not the same, right? If we did 2001 a CAD 0, that is the same as this, but it's not the same as this. That's saying that we have 3 zeros that we dropped, okay? So we can't do that. We have to write out all 4 zeros. That's the most confusing part of this, right? But anyways, so they all have to be the same to change it here. As you can see, it says 0, 0, 0, 0, right? 0, 0, 0, 1. Right, before we were changing here, it'd be 0, 0, 0, and then 1. 0, 0, then 1. So, such as, if we kept moving, they would all have to be the same to, like, so a 72 would have to be the same to the second digit here. And a 76, they'd have to be the same to here. And a 80 would have to be the same to here. Okay, so that's what that's saying. Hopefully that makes sense. If not, let me know. But that's basically subnetting. And if you guys can't, we already went over netting. That's what's not in here. It was in the last one. But if you guys, I don't know, if you have any questions, we'll probably work on this in class 2 or something. But yeah, send me an email. Subnetting is tough. The only way to do it is do practice problems. My suggestion is get a subnetting game and hit it as hard as possible, because subnetting is one thing I can promise you won't go away from exams, and you definitely will see it, and most people hate it. But it really, all you have to do is figure out that the network bits show you where the network is, and the host bits show you where the hosts are. And if you can do that, you're good to go. The host bits show you how big your network's going to be. Anyways, that's the chapter on subnetting. And that's all I have for that. All right, I hope you enjoyed.